So continuous delivery. I just want to make sure that we understand when I say continuous delivery that we're on the same page. So I found this tweet from Martin Fowler earlier this year, and that's how I kind of understand continuous delivery as well. Just so we are clear on that one. It doesn't mean that. So it's not the continuous deployment part where we actually ship it to the App Store or Google Play. It's more preparing. So we at any given time actually have this line. That's how we see it in my team. We want to be able to build a release-ready binary at any given time. Whenever some product owner say, let's ship it, then we'll just click the button, and then we have the binary to upload. So that's what I'm going to be covering today. Sorry. Yeah, and whenever I refer to we, that will be me and the small team that I'm in at eBay Classifieds in Denmark. And so this is going to these are the two apps that we are maintaining and developing, Bilbasen and DBA. If you guys are Danish, most of you are probably familiar with these brands. So it's how we do it on these apps that I'm going to cover, and not all the different options that are out there. Yeah, and here are just some of the tools that we're using. We have selected tools that can support multiple platforms, and with multiple platforms, I do only cover the two major players, iOS and Android. Sorry about that, Microsoft, but I know that Apple has started to get more into actually support UI testing. We just see that as hopefully a benefit that can make sure that Calabash that we use for UI testing can be more stable, since they can work on the same level as Apple does, but we do prefer tools that can cover multiple platforms. So first, let's look at how we do our branching and building and distribution. And with distribution, I do mean how we get our apps for manual testing to test devices within the office. So we are using Git and working with feature branches. So we do have our master branch that will have to be stable at all times, and then we'll just create a new branch whenever we have to fix something. We might need to do a bug fix, so I'll create a branch for that one, the red on top, and fix it. And all the tests and all the stuff that I'm going to call will be running for that branch as well. When I'm done, I'm going to merge it back to master. While someone else in my team might be working on the new cool feature, the yellow-orange color. Actually, I do miss an error here, because once I have merged the red bug fix into master, we'll make sure to also merge from master into the feature branch, so it contains the bug fix as well. Otherwise, we might get reported the bug that was there on the new feature branch, which is not what we intend to do. Working with feature branches also gives us this great benefit in GitHub that we can use a pull request whenever we want to close a feature branch and merge it in, and that's an easy way to do a code review, to only see what has actually changed in this branch. Then we want to make sure, so we're using Jenkins for our continuous integration server, and we want to make sure that all our jobs, building unit test and integration test and UI test, that they run for whatever branch we have in scope right now. And for that, I'm just going to show you how it actually works. So I'm going to create a new branch. And the code name here is that it starts with a feature. It's just a naming pattern that we have selected. So whenever our Jenkins server sees a branch called feature, it's going to create all the jobs required or that we have specified we want. So if I create this branch and push it to Git, then you'll see the jobs on top are just created automatically for me. I don't have to do anything. We used to do this manually, which led to that we didn't do it. So we would just work on the feature branch, and nobody really ran all the tests. Some developers tend to forget to run those on the local machines, and then we'll merge it a few weeks later, or however that branch was living for how long. And then we'll see the errors on the master branch as soon as it ran there. So now it's automated. Push the branch out and get these jobs created. If you look at the master branches, you'll notice that most of them end with a -t, and that's part of our template pattern as well. So what we're looking for to automatically create the jobs we want. That's why you see there are two cloud builds a little from the bottom. They don't have the T. That's because we only run our UI test in the test cloud. I'll come back to that later. From our master branch, we don't do that from feature branches, which is due to you have to pay for each minute you use this. You use devices in the test cloud, so we don't want to do that for all our feature branches. We'll wait with that until to the master branch. So the way we do this, and I'm sure there are multiple ways, I just want to share how we do it. There's this nice little plugin that we're using. It's got great documentation, so you can go in there and read that. What it basically you have to do is create a job, a synchronization job, for each app that you want to do this on. So with this one, we'll make sure that we are in sync with the feature branches we have on Bilbasen, with the jobs that we have available on Jenkins. And we just specify that this synchronization job runs about, I think it's one every hour, or you can do it manually. And this is the setup of the job up there. You basically just include a Gradle script, and these key values down here are all mentioned in the documentation. So you specify what branch it should look for and the name, the template pattern that it should look for in your branches. And then it's happening by magic. And of course, whenever we have merged a branch into master and delete the branch, it's going to delete the jobs again, so it doesn't get cluttered on Jenkins as well. If you did notice, there was one of the from the Jenkins picture right before, there was one dot that was green. That's because I only bothered to run our Huggy app build. So we're using Huggy app for distribution. We used to use a test flight until Apple bought it and and put it into the way they wanted to do it. And now we use a test flight because Huggy app because it's more flexible in the way that we want to do it. So we do actually the image is just part of what we can get from apps. So we create a new app in Huggy app for each feature branch, named the same as the feature branch. So whenever I install the GOTO Copenhagen demo, that's the name I'm going to see on my home screen, so I know exactly what version of the app that I'm starting right now. That's very useful for our manual QA testing and also for UX verification, if they want to see it on real devices, that we haven't messed up any pixels and the flows are what they expect it to do. So that's a job on Jenkins that makes sure that we talk to the Huggy app API and create that one. And also we have hooked into to the list as this the other plugin that makes sure we are in sync with branches and jobs. We have hooked in and make sure whenever it's going to delete a branch, we'll also delete, or when it's going to delete the branch and the jobs, we also delete the app in Huggy app, so we don't leave old apps that are no longer part of a branch behind. So once we have all this set up, we can actually we can build automatically, and we can get it on test devices. And so we could actually also just do the binary to upload. But as you might have noticed from your own machines, just because you can compile and distribute it and run it doesn't mean that the app is actually working, which is what we want to ensure when we do this whole continuous delivery. So the next part is going to be about how we do all our testing. So before we go into testing, there are a few prerequisites you have to ensure, I would say at least. So required are that you have stable test environments, and the S is because if you're lucky, you have more than one test environment. We have 9 duplicate test environments of our DBA platform, shared with the web team, of course, that does their part, and we have our own API for the apps. But there are 9 different very cloned test environments. So we have one of them specified that's where we want to run our stable tests. And they are quite stable most of the time. And then you need good test data on your test environment as well. Each weekend we get a fresh copy of production data into the test environment, so we know that we have at least some valid data. I'll get back to that. Of course, all tests have to be self-contained as well. Whenever you create stuff, we'll cover that. But when you do create stuff, so the optional part is you might want to have some hooks into your test data where you can modify things that doesn't happen in a normal way. For instance, when we create a listing on DBA, put something for sale, it's going to be valid for 4 weeks, but we can wait 4 weeks, and we want to verify that whenever the listing expires, the app behaves correct. So we do have a hook only in our test environment where we can force that event to happen that normally would happen in a batch job. So we can fire that off as part of our test. And then we know the listing should now be expired, and we can verify that in our UI test that that's actually the case. So optional, but still a very good idea. Of course, it depends on what kind of data you have and what you want to test. Yeah, so the different kind of tests that we do have, I'm not going to cover much about unit tests, just of course let you know that we do have unit tests, and like all other platforms, they're super fast, and it's an easy way to test the specific behavior of a given component, but it's happening in isolation. We're using, for iOS, we're using XC-test and some mock objects, and that's about it. I'm not going to go more into that part. Then we do have integration tests, and there are many different opinions about what an integration test is. We mainly use it for actually testing our whole service layer from the app, making sure that we get the expected JSON back, that we can parse it into our models, and that they contain the data we expect it to actually do. So the small mobile team that we're in, we are squeezed in between a web team doing a DBA and another web team doing Bilbasen. So they kind of own the domain layer, and then we also build our own API on top of that serves the JSON back. And even though we have good test coverage on the web platforms as well, sometimes they do make changes that break stuff that they didn't know about until the app finds it. So actually these integration tests quite often, or not quite often, that sounds horrible, but they do sometimes stop potential bugs from making it into production, because we can go to them and say, hey, you guys, you just broke the login feature or whatever it could be, because this is where we can actually parse the JSON. This is much easier and faster to do than from the UI test, which is the last part. So here we're close to the JSON part, and from the UI test, it's how the user sees it. This is where we cover end-to-end scenarios, actually touching the buttons and verifying the UI behave the way it does should be. But it's a lot of work to ensure every field is the way you expect it to do from the UI. That's why we have the integration test verifying that the JSON is parsed correct, and then the rest goes up to the UI. So the UI test is where I'm going to be, the next slides will be about, because I find that to be the hardest part and where people have the most questions when we talk about test. Unit test and integration test are close to the code, and you write it in Objective-C the way you want, and the UI test is where it can be more difficult to actually do it, and there are some pitfalls that you can run into, which I'll be covering. And some of it might be, if you're not familiar with, for example, a cucumber, it might be a bit steep learning curve just to see it, what I'm going to show you, but then at least you should know in back of your head. He did say something about this could be a problem if you start doing it. So hopefully you can easily follow along. So Cucumber and Calabash, any of you using it or familiar with these tools? A couple of hands. Okay, so in short, a Cucumber can be used to test all kind of things, and then you can put in, let's call it a driver that can actually manipulate whatever, if it's web you want to test or if it's some other system. And Calabash is what you can use to test iOS and Android. So the way it works is that Calabash will, for iOS, install a little server component in your app that it can talk to your test, which will be written in Cucumber. So it's going to exchange JSON over HTTP. So it's Calabash, you can tell to swipe on a cell or scroll up and down or press a button and all this. That's the work of Calabash, and Cucumber is the language that you use to actually write your tests. Xamarin, who is behind the Calabash part, has a lot of great documentation if you want to know more about all the nitty-gritty parts of it. But let's dive more into more readable stuff, which is a test scenario. So this is a Cucumber written out, very easy to read. So the picture shows you from within the DBA app, if I want to report a listing that someone has set a low price, or I have suspicion that it's stolen goods or whatever, for any reason it could be, and the tests want to verify that you as a user can only submit a report like this once, and the next time you want to do it, you should be told so. You don't have to read all the lines, but if you've already done that, you should see that it's fairly easy readable, and you should be able to understand what the system is supposed to be doing at all times. Calabash ships with, so if we break it down, this one would be, Cucumber has feature files. It's just a file that contains multiple scenarios. It could be a login feature you want to test, and then you would have multiple login scenarios testing for bad input and when it goes well and all this. And each line in the scenario is called a step. And Calabash ships with some predefined steps, which if you go this way, I would advise you not to use them because they're very general. It would say, then I see, and then in quotation you would put in anmeld annonce, and it will find a text that says anmeld annonce, and that will go well. But the whole idea with using Cucumber is that you can write it in your domain-specific language, which we tend to do a lot. Also, as you'll see, this has to work cross-platform, or we want it to work cross-platform. So we are trying to specify user behavior or user intention and not how it's actually implemented. We probably do fail every now and then, so it would say touch a button or something like that, but it should be closer to just the intention and not how it's actually implemented, because there could be differences between Android and iOS. And this scenario you want to be able to run on both devices. So to make it work cross-platform, these three boxes are what is common from you get from Cucumber. So it got the feature file I mentioned, which contains scenarios, and each scenario contains steps. But then you should make sure that you put in an extra layer, which is the page object pattern. You don't want your logic of touching and querying stuff within your steps. You want to put them one step further down the line, which will be page objects. And then you can make implementation of your page objects for iOS and Android, which we'll see an example. That way, you can reuse your scenarios and steps across the platforms and only make the page object specific to the platform. I just put in that, so to load, you see the file structure right here of where we store all our features and all the tests. So there's an Android and iOS folder. So whenever I want to run my Cucumber test on Android, I make sure to use a -R command on Cucumber, telling it to now load the files that is stored under Android. And running on iOS, it should load the one in the iOS folder. And then, of course, the page objects has to be implemented in both cases, answering for the same methods. So this whole feature folder that you see right here is actually, we store that in a Git submodule, so we can use it from within our Android and iOS app, sharing the same code, the same test code. Yeah, so looking more into the page objects, this is a step definition. And what it does is actually just invoking a page object. So this one is the iOS part of report listing. So the page object is just to encapsulate whatever code is needed to work on that report listing page. So here I want to send the report. And the transition method down at the bottom is a built-in Calabash method that will now tap the view marked anmeld annonce, which is the bottom you saw at the bottom. And then the page it should now navigate to that's something we built ourselves. This previous page, I could have put in any other page object, which is just a Ruby class that will now be in control. So looking at the step, at page variable is going to be in scope for all the steps running in a scenario. And this method is returning the new page. So the next step can say page do something, and that will be the next one in the flow. Xamarin does have an example app called a Crossplatform example, which I encourage you to download and have a look at. They have both how you do this cross-platform part, and also the whole page object pattern split out. But very, very important that you don't start. You'll see I have another example showing how bad we were at putting a lot of code in step definitions, and you don't want to go there. You just want to start out by doing page objects right away. Yeah, that example is actually up right now because these are all the learnings that we had along the way, and one of the major issues we had was timing issues. So don't do it like this. First of all, this is a step containing logic and not put in a page object. But you could have done the same lousy sleep code in page objects, and that would still be bad. Try to avoid that sleep method at all costs. Instead, there's a lot of wait for helpers, wait for something to appear, wait for something to not be visible anymore. Use those instead. It's going to make your life a lot easier. Otherwise, you'll find yourself increasing those sleeps whenever your build server gets a little bit slower. Then you'll just add one, and your test suite is going to run slower and slower, and you still get timing issues that you can't reproduce in your own machine, but only on the build server. And yeah, this is real experiences. It's not something I'm making up. We had those problems. So the same step is now really simple. Now it's just asking the page object to write the price. And the right price is now it's scrolling nice and easy and waiting for a certain cell, it's the price cell, to actually be visible. Then it's going to touch the price cell and use the keyboard to enter the text and close the keyboard again. And all these methods mentioned down here, they'll make sure they wait for example, the keyboard to appear and to disappear again, which is all the sleeps over on the left side that used to do that. So always favor wait for methods prior to instead of sleeping. Sleeping is really bad. Yeah, and of course you want your whole test suite to be stable so you can actually trust it. And the wait for is one good way to get there, but still you can see some flaky tests every now and then, which is actually not to blame for neither your abilities to write the wait for or Calabash. Actually, it's more obviously, most often it's going to be at the lower level UI automation or the simulator on iOS after it's running for I don't know, quite some time. I think our whole test suite for the DBA iPad app takes 1 hour and 30 or 45 minutes. And it really sucks that it's been running for that long. And then you see one little scenario fail, and it failed because the simulator just crashed on you for no particular reason. It just lost the connection or something. So Cucumber come with this. They have Cucumber has different formatters how you want it to output stuff, and one of the formatters is a rerun formatter, which is really nice because then you can specify you want that formatter and tell it to output it to some file, and that rerun.txt file will now contain information about what scenarios failed in the first run, and then you can just ask Cucumber to run whatever is in that rerun text file, and it will run those failed tests again. Of course, to make this work on Jenkins, you need to wrap something around these lines. It could be a rake task or a shell script, because you don't want to report the first part back to Jenkins, because then Jenkins is going to think that it failed and forget about the last one. So you have to encapsulate this in one self-contained runner that will only report back to Jenkins once the rerun has completed as well. It's a little sad that it's necessary to do this, and that's why one of the reasons I said that I hope, since Apple is getting more into doing their own UI test, maybe they can improve the underlying part so we don't have to do this. We do find it a pretty good solution because we don't want to hunt red builds that aren't really red, but just do some weird crash. So rerun formatter is the best of the worst, I would say, the worst choices. Yeah. So the whole idea of doing this is, of course, that we want to be stable at all times, but also provide us as developers with rapid feedback. As soon as we've broken something, we want to know. And that used to work quite good for us, but then we were pretty good at adding more and more tests, and all of a sudden, it took quite a long time to run all these tests. And then the fast feedback kind of disappeared, because then you would do some stuff in the morning, and then you would go to lunch, and then after lunch you might get a report back that some test has failed. So now we do have two different test suites. Oh, well, actually it's the same test suite, but you can use tags in Cucumber. So we do select scenarios in each feature that we want to run after each commit, and then only run the full test suite at nighttime. So we only run a subset of all our scenarios that will cover all the basics of the app right after each commit, and the rest will run at nighttime. That's one way to improve the speed of running your test. The other one is improving your scenarios to be faster at setting up and tearing down whatever data they would need. And for that, Calabash has a little backdoor that enables you to invoke the app without going through the UI. And that might sound like cheating, and it is a bit, but it's not bad, because of course you only do this for steps that you have already covered well in other scenarios. So I'll give you an example. This scenario, I want to see that I can manage my listings in the DBA app and see whatever changes I make. So this used to be the first two highlighted lines. Used to, first of all, do login through the UI, typing the long username, typing the long password, submit it, log in, and then create a listing. That you'll see it's in the past tense. I have created a listing. But at first, this step has to go through the UI, select the classification, write the price I want, and fill out all the required mandatory fields for that flow. And then that's actually first after this step that the real test started, because I wanted to verify that I could change those things that I did. So what we do here is actually using that little backdoor, which is why we can in these codes see. That's why it says using quick login. That's a way for us to remind ourselves that this login is not logging in through the UI, it's using the backdoor. And the differences we were quite happy with the differences in time. So the one on the left is using the backdoor, the other one was without the backdoor. So now it actually took longer to prepare the test data to run than it did to actually do the test itself. So it's a great speed improvement, and we use the backdoor quite a lot in a lot of tests. Of course, again, as I said, only do it when you know you have full scenarios covering the actual login, and also for this part where we create listings, we have other scenarios for that. And this also comes down to that the test, whenever data is required, has to be able to create their own tests. Their own data, so they're self-contained. They can't rely on someone else has logged in previously with a unique seller user and created a listing, because you never know if that scenario will run before the other one or not. So they have to be self-contained, and the backdoor can help improve that quite drastically. So now we have a lot of tests, and they run they run fast and they run stable. But they can still fail, and that's why we want to have visible feedback. So we do get notified in the team that someone has screwed up, and we have to fix something. So this is just a little short, showing a picture from. We have a big monitor in our team space showing only the master builds. That is very important. We used to show all our feature builds up here as well. But since we do have a deal on the team that it's okay for feature branches to be read for some time, since you're actually working on new features and they might not be completely done yet, then we would see red dots on the screen, and you'll start kind of ignoring them until you notice that it said it was the master build. So to deal with that, we just removed all the feature branches from showing on this build monitor, only showing the master. And now we know that if we look up there and we see something is red, someone has to take an action on it. So all the other feature branches there, we just report them into Slack. So Jenkins has a nice little plugin where you can notify in Slack, and we have our own little Slack group where we get notified about builds, also master builds. as this one shows, our cloud build apparently failed here after 14 seconds, probably because it couldn't, I don't know, 0.14 seconds, that's quite fast. But here you can see, yeah, so our DBA all test on iPad takes about 1 hour and 30 minutes to run the whole test suite. So on our Jenkins server, we only run on iOS, at least that is, we only run on the latest simulator that is in the tools that we're using right now. We haven't gone up to iOS SDK 9 yet, so it's right now 8.4 that we use, which is all right. But if you have used the auto layout on iOS, you might have noticed there could be some differences between iOS 7 and 8. We have noticed that at least. So you want to test on real devices as well, and for that we're using Xamarin's Test Cloud, where we can just use all the scenarios that we have, or you can use a tag and specify what scenarios you want to run out there. And then we can select whatever devices we want to run these tests on. So we use our own analytics and find out what combination of OS and hardware most of our users has, and then we select those devices in here and make sure our tests run on that. We have also in the test cloud split out, so we run one test only on iPhones and another one only on iPad. They could actually run in one run together, but we do prefer only have images from one platform. That makes it easy also for UX to go in here and have a quick glance if something looks weird on iOS 7 or 8. On the same platform. It would be a little weird having iPad and iPhone devices in between. So the cloud is really nice. It's going to highlight whenever something has failed, and you can see what was the last step and what did the screen look like at the time it failed. You can click in on any device, and you can see memory and CPU usage for each step. So the lines here will equal one step in my feature file. And then I can see if suddenly I see a big incline in memory usage, I can go back to that specific step and say, oh, that's when they go and look at big images. Maybe that's why it started using more memory. And as you can see, you got the device log and the test log, so you can see what's going on. Yeah, the cloud has saved our bot a few times, as I said, about auto layout, where we have missed something that didn't work out on iOS 7, so some element weren't shown, and our test would catch that for us, which is really nice. So is this test automation, if you do that, then you're going to be happy, and that's about it. Not completely. They're great, and you should definitely do it. They're way faster than any human can do the same test over and over again. And they never forget any details. They always do it in the same order as you instructed it to do, which is also the downside. They only do what you tell it to do. So it's a great way to avoid old bugs and miss. You don't want to have those regressions where an old bug, you can talk to Apple about that. Old bugs might reappear in later versions. A bug on the lock screen that happened in iOS 7 is now back in iOS 9. I'm not sure if it's the same bug, but I thought it was kind of funny. And you don't want that to happen. That's what the automation is really good for. But it's not gonna beat the human brain of thinking for themselves. So manual testing is still very important. But to have the continuous delivery actually working, you should do it as part of your whole story and not do huge test run whenever you're completely done with a feature. So a manual test is part of our definition of done for each story, which means that someone else on the team has to verify it manually that this part is working. It could be our QA expert that we do have on the team, or it could be another developer if the QA guy is busy doing other stuff. But the automated test makes sure that you don't have to spend a lot of time doing the same boring tests over and over again. Our QA can now spend a lot more time doing exploratory testing, using his weird thinking of how he can destroy this nice app and finding bugs that we haven't automated because it does doesn't think for itself, the automated test, and he can focus on areas with the highest risk. And of course, if he does find something very obvious that we can automate, then we'll go ahead and do that to prevent bugs from happening again. But you need the manual test as well. You can totally skip it. And then all this in combination, you have to have a lot of trust. First of all, you have to trust that your entire team is up for this and they want to keep maintaining and writing these tests. It's not one person on the team who should do this all the time. It's a team effort to do it. And very importantly, you have to make sure that your QA actually trusts your whole test suite as well. If he or she doesn't trust it and want to do it manually all the time over and over again, then it's no good. So they have to be convinced about this nice automation as well. And we do trust our QA to find the tricky bugs that we haven't automated yet, which is why we try to give him as much time to do that as possible as a team effort. Also very importantly is that whenever our build monitor is showing something red, we do trust that something is bad and we should go fix it. We do not allow any broken windows just to live on for a few weeks and say it's probably going to fix by itself. We dive in, and sometimes it could be an error in our search indexing on the test environment was not completely right at the time. Well, then we'll rerun the test. It's not proven yet that it's a bug in the app, but we have to investigate and follow up. Lately, we have made that into that. So we have 5 developers. So we have 1 day a week each day where we make sure to dive in if something is red. So we try to share the responsibility for that on the team, which is working quite well. And then we also sometimes take a good look at our code coverage to make sure that we cover the areas that we expect to cover, and that we haven't left out any big parts. And we can also use this to inform our QA that we do have certain areas that we haven't been able to find a good, easy way to automate any tests. So he should make sure to do that manually. Just keep in mind that code coverage doesn't necessarily guarantee that it's a good test. It just guarantees that the code has been touched by some execution. But if you forget to do any assertion in your tests, well, then you might let a lot of bugs go unnoticed. So code coverage doesn't necessarily guarantee that you have a very good test. They just make sure that you have good coverage, at least touching your app, making sure it doesn't really crash. Yeah. So one of the benefits after we had all this set up was that now we can actually. So the first slide was about continuous delivery being something that we could do a binary whenever and upload it whenever we want to. And we want to take advantage of that, actually starting to putting out more frequent releases. But for that to happen, we had to convince our product owner about the new agility that we now have, because they were used to, we should take about a week out of the calendar to prepare an app, do all the testing and the bug fixes because we found the bugs in the last minute, and then fix it. And now they know that we can, like from hour to hour, they would say, can we upload, or in the next sprint, can we do it? Yeah, sure. We just press the button and get the file and upload it. That was made possible also. They were afraid at first that customers didn't want to get annoyed by being told there's a new update. But since Apple also found out that it's a good idea with automated app updates, we do see a very fast adoption rate whenever we put out a new release. So it's not really a big problem anymore to do rapid releases. And we do help our product owner defining the scope, saying, and now would be a good time. And if we want to release this, then I know at least 2 bugs I would like to fix and go out in the same release. So we do help each other defining the best release scope for each app release. We also did find that we had to prepare our app a little bit for it. First of all, we have built in a kill switch, because, well, it means that we do have a lot of old versions running, and at one point you want to start closing the old ones to force people up on the new ones. It's only like a percentage or something of the users that are stuck at old versions. But we do have a switch so we can start bugging them on each app start that, hey, there's a new app in the App Store, you should go get it. So we can soft close it and warn them every now and then. And eventually we can do a hard close, and it's just going to say you can't use this version anymore. You have to go and update. which is also a good emergency brake in case we do send out an app that would crash for some reason. And that can actually happen despite you doing automated test or not. So a kill switch is a good idea. Also, welcome screens. You see that in a lot of apps. You want to tell your users what's new in this one, because they don't really, at least that's what we see it. They don't really go into the App Store and read what's new. They just see the blue dot at iOS on the home screen saying, oh, this app has been updated. They have no idea what they just got, cool new features. So you want to be able to tell it within your app that something great is up in this new app. So you have this all set up. And if you want to make your app upload even easier, you could look into Fastlane tools for iOS, which has a lot of easy ways to do screenshots and prepare your iTunes Connect. There's still this whole part about it being the app world, so you actually go onto people's devices, and it's you can't just deploy it to a server. But with all this set up, I kind of envy my dog for looking really relaxed. This is the feeling you should have after you upload and all your automated tests are green. Just on your back, really comfortable. No worries, I'll just click the button to release it in the App Store whenever it's ready. If you don't have that feeling, then you have to go back to the slide with the trust and see if you have any trust issues in your team. That could be related, that you're still a little worried, is this going to be okay or not? And if you don't have any trust issues, then the last option is to just remember to embrace failures. Because you don't get bug-free software no matter how hard you try. There's still going to be bugs in there. What the best you can do is to learn and improve from your bugs and build in new tests to prevent any bug that you've seen from happening again. Apple could have done that with a lock screen so it wouldn't have reappeared in iOS 9. And also, instead of when someone has created a bug, the test is read or something, instead of blaming the developer and running a git blame game or whatever, turn it around and say, hey, it happens because we all are just human beings who we're coding. Just celebrate that you have a cool setup that will catch these things. So you turn it into a positive thing and say, yes, we have cool test coverage automatically. It just turned red because someone made a mistake. That's not the case. Let's celebrate the test that found the bug instead. And remember to know your app quality at all times. So together with our build status, we do have a screen showing so this is from criticism. If you see spikes happening, you should take action before your users start to report it to customer service or whoever gets those or bad App Store reviews. Take action immediately. So make sure that you know your app quality. And when stuff like this spike happens, be happy that you, within an hour, can run in and fix the bug and click the button and build a new file and upload it and get it out right away if that does happen. I should know that this was actually not part of an app release. That was a third-party component that did this. I just wanted to show that we could take action right away. Of course, we didn't do that bug ourselves. I swear. I think that's actually it. How am I doing on time? Yes, and remember to rate the session from within the app. And any questions? No questions. Yeah.
How do you submit to App Store or Play Store? Do you have some kind of gate there as well?
No. We have this deal that our product owner prepares iTunes Connect because they know what they want to write. And actually, it's very rare that we do change, for instance, the images we have in the App Store, because that's why I mentioned the welcome screen. We want to highlight what's new within the app, because most people coming back to the same app don't really notice what's in the App Store. New customers, of course, will see it in there. But we only have we only support Danish in our app. But if we were to support multiple languages, I would definitely look into the Fastlane tools for iOS, which can do a lot of help for actually submitting to the App Store if you want to automate more into that part. But our automation stops so Jenkins can build and sign the correct API file for uploading. We don't have to do anything about it. That's just clicking a button manually and it will be ready with the binary to upload. but the rest we still handle manually because it's so easy to do for us with only one language. But fast lane tools is definitely something that I would look into if I had more languages to support.
I was wondering, I assume you do analytics and like tracking of some sort of key performance indicators for eBay and the native apps as well. If you do that, how do you automate tests for this?
Well, I didn't hear the first part.
Do you track like like user engagement and things like this in your application, and like analytics in your application? And if you do you have automated tests for this as well?
No, we don't have automated tests for that. It's on our list that we want to hook in and verify that we do the right tracking. We do have a project coming up where we have to improve our tracking using global-based eBay names for certain things. And I think in that respect, we might have to look into collecting the tracking somewhere and then verify it afterwards, but we don't at the moment. But it's a great idea. So if you have a solution, I would love to hear about it. Any more questions? All right. Well, thank you for coming.